Okay, we're doing daily work unit 10-2. I'm going to leave the blanks this time so we can see what it's asking for. Don't want to miss any of the directions. It says round to the nearest hundredth. We don't want to miss that. That's in fine print up there. We want to write down the area formula. We're looking for the area of a parallelogram. So the formula for every parallelogram is base times height. So we're going to have area equal base, which the top and bottom are congruent because opposite sides of a parallelogram are equal. So the base is 21 centimeters times the height, and the height is how tall it is from top to bottom. So the height is not the 8, the height is the 7 centimeters. So we're going to multiply. You multiply the numbers. 21 times 7 is 147. And you multiply the names and you get a new name. And when you multiply with like bases, you add the exponents, centimeter square or square centimeters. But we didn't want the answer in square centimeters. We wanted it in square decimeters. So we need to lose the name centimeter, square centimeter, and gain the name square decimeter. Now, which one's bigger? Well, centi is bigger. Excuse me, deci is bigger. Well, how many centi are in a deci? 10. You can study your metric chart. But we're not talking about deci and centi. We're talking about square deci and square centi, so we have to square our conversion. So 1 squared is 1 and 10 squared is 100, so there's actually 100 square centi in a square deci. So we're losing the name square centi and we're gaining the name square deci. We multiply and we have 147 square deci over multiply 100. When you divide by 100, it shifts the decimal 2 places, so you get 1.47 square deci. But the directions are round to the nearest hundredth. We are in the hundredths, so that's good. 1.47 square deci for area. Any questions on that? I'm going to do perimeter up here just because of space. Perimeter is the sum of the sides, which is 2 sides at 8 centimeters, plus the other 2 sides at 21 centimeters, plus the other 2 sides at 21 centimeters. You got 2 lengths that are equal and 2 widths that are equal. Opposite sides are equal, so that was also 8 centimeters, you see. So we're going to do the multiplication to simplify. Now I'm going to white out my area stuff just to move it out of my way. So we're going to have perimeter is equal to 16 centimeters plus 42 centimeters. And now we're going to add, so we have perimeter, we would have perimeter is equal to 58 centimeters. But we want it in decimeters, so we need to lose the name centi and gain the name deci. The bigger is deci, so one of those is how many centi? 10. It's deci to the first, sin out of the first, so we have 1 to the first, 10 to the first, so they stay the same. We're losing the name centi, gaining the name deci. When you divide by 10, it moves the decimal one place. And so we're going to have 5.8 decimeters. Any questions on number 1? Okay. We'll let you work on the other two. Don't forget about Pythagorean theorem and trigonometric ratios. On this set, let's do number 6. We've got a triangle. The formula for area of a triangle is 1/2 base times height. So we get area equal 1/2 times the base, which is 12, times the height, which we don't know. The height is not even drawn, so we would need to draw it. It would be straight down. This is an equilateral triangle. All sides are equal. If it's equilateral, it's also equiangular, and each angle of an equiangular triangle is 60 degrees, so this is 60 and 60, and the one at the top was 60. We've got 2 out of the 4 pieces of the isosceles triangle theorem, so we know that this must be the vertex angle bisector, and so that's 30 and 30, and this bisects the base, so this is 6 and 6. So if I extract that triangle, then this is my height. That's a right angle. This is 6. This is 12. This is 60. This is 30. I can either use the Pythagorean theorem or my 30, 60, 90 triangle rules. I'm going to use my 30, 60, 90 triangle rules. Long leg equals short leg times the square root of 3. Short leg is 6. Therefore, long leg is 6 square root 3. I used it instead of Pythagorean theorem because it was going to be easier to use it instead of the Pythagorean theorem. So my height, which is my long leg, is 6 square root 3. So the area is 1/2 of 12, which is 6 times 6 is 36 square root 3. Any questions on that? For those in number sense, you might memorize or calculate or mathematics competition that if you want the formula for the area of an equilateral triangle, it's going to be 1/2 a side square, square root of 3. 1/2 of a side, quantity square, square root 3 for the area of an equilateral triangle. So we could say 1/2 of 12 is 6 squared is 36 square root 3. 1/2 a side, 6 square, square root of 3. 1/2 a side square, square root of 3 gives you the area of an equilateral triangle. Okay? We've got rhombuses, rhombus, form half, diagonal